So let's deal with the what you mentioned first. What is a calorie? Because I think a lot of people don't quite understand this. So a calorie just refers to a unit of energy, of heat specifically. And so, well, what does that have to do with food? What does that have to do with like what we digest and eat? Really what you're talking about is the potential chemical energy that is in the bonds of the macronutrients of food, right? And by digesting, assimilating, and metabolizing those nutrients, we're able to create energy. And the end product of that mostly is ATP, adenosine triphosphate, which is your body's energy currency. So to understand ATP, just try to think about if you're trying to power these various reactions in your body, and we're talking about tens of thousands of enzymes that require ATP, it doesn't make sense that you would have to create a bunch of micro explosions, right? You want something that can transfer high energy phosphates to power these reactions, to give up essentially its energy to power something that might otherwise be unfavorable. So a lot of metabolism is simply creating ATP, which the end of the line of that, I'm going to kind of work backwards, is what's called oxidative respiration. So that happens in the mitochondria. Everybody's heard mitochondria, powerhouse of the cell. And that is done through essentially creating a hydrogen ion gradient across the mitochondria, which powers the production of ATP by converting free phosphate plus ADP to ATP. Now, the way that hydrogen ion gradient is created is through creating hydrogen ions that can be donated through the Krebs cycle. Now, the Krebs cycle is linked to glycolysis. So if we talk about carbohydrate metabolism, carbohydrates basically, other than fructose, get converted into glucose, which can go into glycolysis, and you can produce some ATPs through glycolysis, and then it boils down to pyruvate, then acetyl-CoA, which goes through the Krebs cycle, produces a lot more ATPs from that. If you talk about protein, protein's a little bit different because protein gets converted to amino acids, which can be used for muscle protein synthesis or protein synthesis in other tissues. But it also can be converted through gluconeogenesis to glucose. And there also are some ketogenic amino acids as well. And so you can have a few different ways to get to the Krebs cycle, either being through acetyl-CoA or through glucose going through glycolysis to pyruvate. Then you have fatty acids, which are able to create energy through what's called beta oxidation, where essentially you're taking these fatty acids and you're lopping them off 2 carbons at a time to produce acetyl-CoA, which again can go into the Krebs cycle, produce those hydrogen ions that can then power the production of ATP. So that's kind of like at the cellular level of how this stuff works. But stepping back and taking it back out, like, well, what does that have to do with weight loss or weight gain, right? Well, when you think about the balance of energy in versus energy out, sounds very simple. But let's look at what actually makes up energy in versus energy out. First of all, you've got to realize that the energy inside of the equation is more difficult to track than people think, right? So one, food labels, which we like to think as being, like from upon high, can have up to a 20% error in them.
Really?
Oh, yeah.
So 100 calorie, something listed as 100 calories per serving, what's actually in there could be 80 or 120.
Right, exactly.
Huh.
So that's one aspect of it. The second aspect is there's what's called your energy, but then there's also metabolizable energy, right? So if you have food stuff with, say, a lot of insoluble fiber, typically insoluble fiber is not really digestible. And so you could have, quite a bit of carbohydrate, but if you can't extract the energy from it, and typically this is because insoluble fiber from like plant material, the carbohydrate and even some of the protein is bound up in the plant structure, which makes it inaccessible to digestive enzymes. And so this is what like adds bulk to your stool and whatnot. But again, reduces the metabolizable energy in there. And there's some evidence that based on people's individual gut microbiome, that some people may actually be better at extracting energy out of fiber compared to other people. So just starting off right there, okay, there's